Hi, so let us do some questions on Wheatstone Bridge. I have selected some questions, so we'll be doing one by one. We know that in a balanced meter bridge, for null deflection in meter bridge, null deflection means zero current is flowing through this middle arm, through galvanometer. So when this happens, when zero current flows through galvanometer, then the ratio of the resistance and its corresponding length, its parallel length is same. Means R1 upon L1 is equal to R2 upon L2. So here R1 is R, L1 is this length, R2 is S and L2 is this length. Now you have to determine the value of R and S in this question. So you need to know two unknowns, and for knowing two unknowns we need two equations. Here we have given two conditions. Condition 1 is that a null point is found at a distance of 60 centimeter and total length we know that is 100 centimeter, so the remaining length is 40 centimeter only when R and S is connected only. This is condition 1. Condition 1. Now condition 2, let me convert it into condition 2. When a resistance of 5 ohm is connected in series with S. Here you connect 5 ohm. Now the scenario is changed. The resistance is changed. So the balanced point will also be changed. Larger resistance will have larger length for balancing. So this balance point will be shifted somewhere here. And we find that it balances a length of 50 centimeter. Okay. Now in second condition, L1 is given 50 centimeter, L2 is given 50 centimeter, and R1 is R itself, and R2 is changed from S to S plus 5. So we have two conditions, and we will be formulating two equations for knowing two unknowns. So for condition 1, R1 is given R only, length is 60 centimeter, R2 is S and length is 40 centimeter. So when you simplify the two, you get that 2R is equal to 3S, and therefore R is equal to 3 upon 2S. So this is your equation 1. Now for second condition. For second condition, again you will be applying the formula R1 upon L1 is equal to R2 upon L2 for a balanced meter bridge for null deflection. In meter bridge, in a meter bridge. ठीक है, फिर आपका जब नल डिफ्लेक्शन होगा और तब आपका देखिए यहाँ पे रेजिस्टेंस चेंज कर गया है, कॉरस्पॉन्डिंग आपका लेंथ भी चेंज कर गया है, एंड आई विल बी पुटिंग वैल्यूज ऑफ R1. R1 इज सेम R, L1 इज चेंज्ड. अब ये L1 आपका 50 हो गया, 50 हो गया. R2 is S plus 5 and L2 again is 50. centimeter. So cancel these lengths, and it implies that from 1 it implies that in place of r I'll be writing 3 upon 2s, and this is equal to s plus 5, and finally you comes to the this step 3s minus 2s upon 2 is equal to 5, and therefore s comes equal to 10 ohm. Now putting value of this s into equation 1. In equation 1, r is equal to 3 upon 2s, and this is equal to 3 upon 2 into 10, and this is equal to 15 ohm. So we find values of s is equal to 10 ohm, r is equal to 15 ohm. Yes. Now next question. Next question. In this question, similar question is this. You have to do the two equations, but here you had the one more resistance is connected in series with S, but here you have one more resistance is connected in parallel to S. So everything is same. You have to formulate two equations for two unknown. So condition 1, R1 is equal to R, R2 is equal to S, and L1 is equal to 40 centimeter, and L2 is equal to 100 minus 40 centimeter. This is equal to 60 centimeter. So this is condition 1, and condition 2. You have R1 the same, R only. R2 has changed. Two resistors which are in parallel. So we will be finding the equivalent of these two parallel resistors, that is 12S upon 12 plus S. So this is your R equivalent. And L1 has changed due to this parallel combination of resistors. Now L1 is obtained at 50 centimeter. And L2 is also 100 minus 50 centimeter is equal to 50 centimeter. So we need to know these four things. The two resistors and what is the length corresponding to these resistors. We know that for null deflection, R1 upon L1 is equal to R2 upon L2. Therefore, condition 1. Condition 1. R1 is R, L1 is your 40 is equal to S upon 60. So cancel these two times, it will go 3 times. It implies that 3R is equal to 2S, and this implies that R is equal to 2 upon 3S. This is first condition, first equation. This is first equation from condition 1. Now from condition 2. Condition 2, for null deflection, we know that R1 upon L1 is equal to R2 upon L2, and here R1 is R only, L1 has changed, L1 has become 50 is equal to, and this R2 is changed. 12s upon 12 plus s, and this divided by 50 centimeter, and this also is centimeter, so these two are cancelled. Therefore R comes equal to 12s upon 12 plus s. Now from 1, when we put the value of R in this equation 2, on putting value of R from equation 1, we find that two upon 3s is equal to 12s upon 12 plus s. So cancel these s from the two sides and let us simplify. So 24 plus 2s is equal to 36. It implies that 2s is equal to 36 minus 24, and this is equal to 12, and therefore s comes equal to 6 only, 6 ohm. And R from equation 1 we can obtain. Now from equation 1, R is equal to 2 upon 3s, and this is equal to 4 ohm only. So answer, S we obtained 6 ohm and R we obtained 4 ohm. Now next question. A resistance of 2 ohm is connected to one of the gaps in a meter bridge. Okay, this R is equal to of 2 ohm, which uses a wire of length 1 meter as unknown resistor. This resistor is greater than 2 ohm, is connected in other gap. The balance point is noticed at L from the positive end. Okay, this is balanced point for first condition. And when you interchanging R and X, it is found that balanced point further shifts by 20 centimeter. So when you interchange, when X is applied along this end and R is applied along this end, then balanced point is changed. And it has increased, further shifted by 20 centimeter away from end A. Now this length is changed from L to L plus 20, new balanced point, and here the remaining length will be 100 minus L plus 20 centimeter. So we have two conditions. This is condition second, and here we have condition first. So for two unknown, because we have to find out unknown resistance X used, and we have two unknowns. Okay, length also is unknown, length is not given and X is not given. So we will be formulating two equations. Now for null deflection means there is no current flowing through galvanometer. When no current flows through galvanometer, then ratio of R1 to L1 must be equal to R2 upon L2. R1 upon L1 is equal to R2 upon L2. And it implies that 2 upon L is equal to X upon 100 minus L. This is first condition. From first condition, we get one equation. Now from second condition, R1 upon L1 is equal to R2 upon L2. It implies that R is converted, interchanged from R2. Now here X upon, and L also is changed. L plus 20 is equal to 2 upon 100 minus L plus 20. So let us simplify this. X into 80 minus L is equal to 2L plus 40. Now let me put value of X from equation 1. From here you can obtain value of X. It implies that X is equal to 2 into 100 minus L upon L. So we will be putting value of X from 1 at this place. Therefore, in place of X we will be writing 2 into 100 minus L upon L into 80 minus L is equal to 2L plus 40. So it implies that 200 minus 2 can be cancelled from both the sides. It will be easier. So on cancelling 2 from two sides and on multiplying the two equations, 8000 minus 100L minus 80L plus L square is equal to, I have cancelled 2 from both the sides, it becomes equal to L square plus 20L. So L square is cancelled from both the sides, and it implies that we are taking the two terms on the other side, then it becomes equal to 200, L is equal to 8000, and it implies that L is equal to 40 centimeter. So I obtained L. Now putting value of this in any one equation, we can, like in equation 1 only, we can find value of X. So in equation 1, X is equal to 2 into 100 minus 40 upon 40. And this is equal to 60 upon 20, and X is equal to 3 ohm only. Answer. Now I conclude. Next question. The given figure shows the experimental setup of a meter bridge. The null point is found to be 60 centimeter away from end point. Look here. Null point is 60 centimeter away. So here the remaining length is 40 centimeter. When a resistance of 15 ohm is connected in series with Y, the null point is found to be shift from 10 centimeter towards the end of A. Null point has shifted 10 centimeter towards A. So the remaining length is 50 centimeter. And here the second length also is 15 centimeter. So let me frame equations. For first case, x upon 60 is equal to y upon it was 40. On simplifying, we find that 2x is equal to 3y. This is equation number 1. Now I am framing second equation. When x divided by, now the remaining length is 50, is equal to y plus 15 is equal to divided by 50. So when you cancel the 2, you find that x is equal to y plus 15, and from 1, 3y upon 2 is equal to y plus 15. Therefore, 3y minus 2y upon 2 is equal to 15, and therefore y comes equal to 30 ohm. Now putting this value in equation, in any equation, in this equation also, putting the value in equation 2, we find that x is equal to 30 plus 15, and this is equal to 45 ohm. So we obtain x and y. Now the question is a different one. Question is the case third. Now we are to simplify for case 3. When a resistance of 30 ohm were connected in parallel with y. When a resistance of 30 ohm is connected in parallel to y, then R equivalent is equal to 30 into y upon 30 plus y, and this is equal to, okay, it will come equal to 30 upon 2 means 15 ohm. Then R equivalent of this gap comes 15 ohm. So find the position of null point if a resistance of, okay, what is the null point? So x has come equal to 45 here. Here in first gap, x is equal to 45 ohm. Second gap is equal to 15 ohm. Now balanced point we have to find, since R1 upon R2 is equal to R3 upon R4, or better I should write R1 upon L1 is equal to R2 upon L2. Okay, it implies that 45 upon L1 is equal to 15 upon 100 minus L1, and this balanced point L1 we have to find. It implies that 4500 minus 45 L1 is equal to 15 L1. It implies that 60 L1 is equal to 4500. Therefore, L1 is equal to 450 by 6. So, upon 2, and this is equal to 75 centimeter. So therefore L1 balanced point is, therefore balanced point is 75 centimeter from initial point. So I